Right triangles, 8.2. So we'll talk about two special right triangles. These two special right triangles are very important. They come up a lot when they'll come up again when we talk about trigonometry. They'll come up again when we talk about area of polygons. So what we're talking about today is not just a one-time thing. You go on to pre-calculus and you start talking about the unit circle. So trigonometry, it's all about special right triangles. So it's an important, special right triangles are an important topic. So the first one we're going to talk about is a 45-90 triangle. And to figure out how these work, we're going to start with a square. So there's my square. And we know that that's a 90-degree angle. And we'll say the sides, to start, the sides of the square are 1 and 1. If I draw the diagonal of the square, like so, what does the diagonal do to these angles here? Cuts them in half. So these are 45 degrees. So 45-45-90 triangle is half a square. And that's part of the reason why they work the way they do. All right, so let's find the length of the diagonal. What side of the triangle is a diagonal? The hypotenuse. So I'm going to label that hypotenuse. On the other two sides of the triangle, since this is an isosceles triangle, these two sides are the same. Two sides are the same, these two angles are the same. We call the other two sides legs. So one is going to be a leg, and it's going to be a leg. So the hypotenuse, let's find the length of the hypotenuse. Let's call it, so we'll call it C for our, so we have C squared equals A squared plus B squared, 1 squared plus 1 squared. So C squared equals 1 squared plus 1 squared is 2. Take the square root of both sides, so C equals the square root of 2. All right, let's now change the length of the leg to 2. And we'll find the length of the hypotenuse there. What we're looking for is a pattern. So here we get C squared equals 2 squared plus 2 squared. So C squared is 4 plus 4 is 8. So C equals the square root of 8. And let's write that in simple radical form. 8 is square root of 4 times 2, which equals 2 square root 2. And let's do one more, and then I think we'll see the pattern. Let's make that side length 3. So we get C squared equals 3 squared plus 3 squared. So C squared equals 9 plus 9 is 18. And C, we take the square root of both sides, the square root of 18. And we can separate that into two numbers. We can take the square root of 1 easily. So we get 3 square root 2. So let's look at our answers here. Here we got square root of 2. How many square roots of 2 do we have here? 1. 1 square root 2. Here we got 2 square root 2. Here we got 3 square root 2. How is that related to the square? 1 square root 2, 2 square root 2, 3 square root 2. And if we kept going, we would see that it worked that way no matter what we did. So what we can say is the hypotenuse on a 45, 45, 90 is square root of 2 times the length of the leg. And what we're going to do is make a nice diagram showing how this works in just a second after we talk about the 30, 60, 90 triangle. So for a 45, 45, 90, the hypotenuse is always square root of 2 times the length of the leg. No matter how long what the length is, because of the Pythagorean theorem, the hypotenuse is square root of 2 times that long. All right. So question's this. So that's our first special right triangle. The next one is a 30, 60, 90 triangle. So for this one, let's start with an equilateral triangle. All right, so in an equilateral triangle, we know that the sides are all the same. I'm going to start with the side length being 2. What are all the angles in an equilateral triangle? 60. So this angle is going to be 60 degrees. Now what I'm going to do with this equilateral triangle is cut it in half. And I'm going to make that a 90-degree angle there. Well, if I make this a 90-degree angle here, what does that do to this angle up here? Cuts it in half, right? There's a 30, 60, 90 triangle. 30, 60, 90 triangle is half an equilateral triangle. All right, so this red perpendicular segment here cuts this angle in half. What does it do to the base of the triangle? Cuts the base in half too. So how long is this side? 1. And what we're going to do for the 30, 60, 90 triangle now, we have our little right triangle here. We're going to find the length of this red segment. Let's call that x. Would that be the hypotenuse of this triangle? No, the hypotenuse is that side. So this is, for this triangle, this side would be C. I could call this A and this side B. All right, so we're going to use the Pythagorean theorem on this triangle. And I'm going to say x squared plus 1 squared equals 2 squared. So x squared equals, or x squared plus 1 equals 4. Subtract 1 from both sides, and I get x squared equals 3. Take the square root, x equals the square root of 3. And we're going to go through a similar process that we did with our square. Now I'm going to make this side 4. If this is 4, how long is this side going to be? 2. How are these two related? One is how many times as long? 2 times as long. This side is 2 times as long as that side. That's always going to be the case. Now let's find x for this one. X squared plus 2 squared equals 4 squared. So x squared plus 4 equals 16. Subtract 4 from both sides, I get x squared equals 12. X equals the square root of 12. And we want to write this in simple radical form. So that's 4 times 3. So we get 2 square root 3. And let's do it one more time, and I think we'll see the pattern. Let's do this as 6. That makes this side how long? 3. Right, so the hypotenuse is always twice as long as this piece of the 30, 60, 90 triangle. And we'll do our Pythagorean theorem again. X squared plus 3 squared equals 6 squared. So x squared plus 9 is 36. Subtract 9. X squared, 36 minus 9 is 27. And then we want to write that, we want to take the square root of 27, which is 9 times 3, and we get 3 square root of 3. All right, how many square root of 3's do I have here? 1. Here I have 2. Here I have 3. And if we kept going with this pattern, we'd see the pattern repeats. So on our 30, 60, 90 triangle, we call this side is the hypotenuse. The hypotenuse of the triangle is always the hypotenuse. We call this side the short side. Short side across from the smallest angle. And we call this the long side. And what we saw here is that the long side is square root of 3 times the short side. And the hypotenuse is 2 times the short side. And this works no matter what the side lengths of our 30, 60, 90 triangle are. This will always work out this way. And this comes from dividing an equilateral triangle in half and using the Pythagorean theorem. So what this lets us do is just knowing one of the sides of a 45, 45, 90, or one of the sides of a 30, 60, 90 triangle, we can figure out all the rest without having to use a Pythagorean theorem at all. So let's turn this into a nice little diagram that we can use to help us when we're working on these problems. All right, questions on what we did here to come up with this? Okay. All right, so here's our diagram. I would recommend that you put this maybe on the top of a page of your notes because it's going to be very helpful to be able to refer back to this. So for our 45, 45, 90, let's draw our triangle. Grab a different one, and what's that one? I'm going to move it a little bit. I'm going to make it a little bigger. So on these kinds of problems, I recommend that you always label the sides. On 45, 45, 90, these two angles are the same, these two sides are the same. So the legs are always going to be the same. And we'll call this side the hypotenuse. To go from either leg, doesn't matter which one, to the hypotenuse, we multiply times the square root of 2. So we make it bigger by multiplying by the square root of 2. Square root of 2 is a little bit bigger than almost 1.5. To go from the hypotenuse to the leg, to go the opposite direction. What's the opposite of multiplication? Division. We're going to divide by the square root of 2. So that's the only rule we need for 45, 45, 90. To go from the leg to the hypotenuse, multiply by the square root of 2. Go from the hypotenuse to the leg, divide by the square root of 2. Really easy rule. You don't have to use a Pythagorean theorem at all. And the two legs are the same. All right, and for a 30, 60, 90. We'll draw two pictures for this one because it makes it less confusing. So here's our triangle. There's our 90-degree angle. 60 degrees, 30 degrees. On the 30, 60, 90, we're going to label our sides. The hypotenuse is always the hypotenuse. All right, guys. The short side is across from the 30-degree angle. Smallest side is across from the smallest angle. And the long side's across from the 60-degree angle. To go from the short to the long, to the hypotenuse, multiply by 2. To go from the short to the long side, multiply by the square root of 3. And we could do this, we'll do this all on the one picture, I think. To go from the hypotenuse to the short, so going the other direction. What's the opposite of multiplying by 2? Divide by 2. And to go from the long to the short, opposite of multiplying by the square root of 3? Divide by the square root of 3. So that's all we have to remember. Multiply or divide by the square root of 2 for a 45, 45, 90. Multiply or divide by 2 for the hypotenuse, or square root of 3 for the long side. That's all we have to remember. So we know one side, we can find any of the other sides. For the 30, 60, 90 triangle, the short side is the key. So if we need to go from the long to the hypotenuse, we find the short side first and then find the hypotenuse. The short side is the key. So all I want to do next is just work on a few examples of working with these special right triangles. Questions there? Okay. Let's look at a few examples. We'll start with an easy one. And this problem says find x. So what I recommend that we do on these is label your sides. Is x the leg or the hypotenuse? And 5 is a leg. We only have legs or hypotenuses on 45, 45, 90. How do we go from the leg to the hypotenuse on a 45, 45, 90? Multiply by the square root of 2. So x equals 5 square root 2, and you're done. And that's it. Yeah. What if this problem asks us for what if this problem had a y here? What would y be? It'd be 5, right? These two sides are the same. The legs are the same. So y equals 5. The two legs are the same on a 45, 45, 90. The hypotenuse is square root of 2 times. All right, let's do one where we have to do a little more work. What if our problem was set up like this? Well, this is a 90-degree angle and these two sides are the same. What does that tell us about these two angles? They're the same, so what do they have to be? 45 degrees. This has to be a 45, 45, 90. If those two sides are the same and that's a 90-degree angle, these angles have to be 45 degrees. So sometimes they'll give you the problem and you'll have to figure out that it's a 45, 45, 90 or 30, 60, 90. All right, so this one we say, all right, so let's label our sides. Is 8 the leg or the hypotenuse? All right, so that makes this the leg. How do we go from the hypotenuse to the leg? Divide by the square root of 2. So x equals 8 divided by the square root of 2. And do you remember what we have to do, what we like to do when we have a square root in the bottom, in the denominator? We want to, what we call rationalize. So I multiply by the square root of 2 over the square root of 2. Whatever's in the bottom, I multiply by that. So on the top, I get, going to multiply straight across, 8 times the square root of 2. Square root of 2 times the square root of 2 is square root of 4. I can multiply inside the square roots. Square root of 4, and the square root of 4 is 2. So the square root of 2 times the square root of 2 is just 2. And now these numbers that are outside the square root, I can divide them. So 8 divided by 2 is 4. 4 square root 2. If you left it as 8 over square root of 2 and the problem asks you to write it in simple radical form, that would be a small deduction on the quiz right there. Yes. Yes, you would get points off. Small deduction, but you would get points off. Because this is simple radical form, this isn't. All right, I want to look at one other example with a 45, 45, 90, because a lot of times with these triangles, people think, oh, there's always a square root of 2 in the answer. And I want to show that that is not necessarily the case. So let's look at another one. Here's my triangle for this one. And we'll set this one up like so. So we want to find x. So let's label our sides. X, what side is x? Hypotenuse, that makes this a leg. And how do we go from a leg to the hypotenuse? Multiply by the square root of 2. So x equals 3 square root 3 times the square root of 2. And the numbers inside the square roots I can multiply. So I get 3 square root 6. So you don't necessarily always have a square root of 2 in an answer that has to do with a 45, 45, 90. And same with a 30, 60, 90. You won't always see a square root of 3 in your answer. All right, questions there? Okay, let's look at a couple of 30, 60, 90 triangles. And this problem says, find the missing sides. So on these problems, always label your sides. I recommend that you always label your sides first. So what side is this one? Short, long, or the hypotenuse? Short. And if we do the short, this angle has to be the 30-degree angle. What side is this one? Long. And the hypotenuse is always the hypotenuse. And now we just use our rules. To go from the short to the hypotenuse, what do? Multiply by 2. So the hypotenuse, 5 times 2 is 10. And the long, to go from the short to the long, multiply by the square root of 3. So we have 5 times the square root of 3. And that's all we have to do. All right, let's look at one more. Just where we have to do a little more work, but not a lot. For this problem says find x. So let's label our sides. What side do we have here? That's the long side. This side? And this side has to be, hypotenuse is always the hypotenuse. Well, we don't have a rule that goes from the long side to the hypotenuse. What do we have to do? The short side is the key. Find the short side. So we know how to get from the short side to the hypotenuse. That's easy, right? All right, so to go from the long to the short, what do? Divide by the square root of 3. So the short side equals 6 square root 3 divided by the square root of 3. Square root of 3 divided by square root of 3 is square root of 1, which is 1. Anything divided by itself is just 1. So we get 6. So that side's 6. Now we can do this to go from the short to the hypotenuse. Multiply by 2. So x equals 12. So we had to divide by square root of 3 and then multiply by 2. The short side is the key on a 30, 60, 90. All right, we good? Okay. Homework is just practicing with these, and we're going to do a little activity to practice with these also. So our homework, page 504. And the homework is not going to be due until our class after